Is this mic working by any chance at the back? Can you hear? Okay, let's start the evening. So it's a great pleasure to welcome you all to this Imperial College inaugural lecture by Professor Kam, the Ken and Mary Minton Chair of Renal Medicine. It's a pleasure to welcome Fred's wife, Kathy, his many friends, and many colleagues past and present that I see around the room. I think it's a great tribute to Fred that so many people have come from miles around, including other countries, in fact, to be here this evening. A particular welcome, obviously, to Mrs. Mary Minton, whose family generously endowed this chair we're celebrating this evening, her son, Mr. Paul Minton, and friend, the Father Grant W. Holmes. We're also fortunate to have with us Mrs. Indira Burman, who's another very important supporter of renal medicine at Imperial College. So thank you all very much for making it. Finally, I'm delighted that Professor Alice Gast, President of Imperial College, has been able to make it to this talk this evening. So I've known Fred as a friend and colleague for over 25 years. In fact, it might be nearer 30 now. But you'll be pleased to hear you're only going to get the short version tonight, because obviously it's Fred's evening, and I will not say too much. So Fred came to the UK from Hong Kong at the age of 17. He came to the World College of the Atlantic, which is an international school in Wales, on a scholarship from Hong Kong. And from there, amazingly perhaps, he obtained a scholarship to Selborne College, Cambridge, where he excelled and was awarded several further scholarships and other forms of support. So having qualified in medicine, Fred did his early house jobs in the Cambridge area, but then moved as senior house officer to Leicester. And it was at Leicester that he first developed an interest in renal medicine. I don't know if we have any Leicester colleagues. Oh, great, we do have Leicester colleagues. Thank you. So working with the late John Walls and John Feely and others, Fred really tucked into renal medicine and enjoyed that greatly. After further training, he then came down to Hammersmith Hospital, in fact as registrar in respiratory medicine and infectious diseases, with John Cohen, Philip Ind, and others. And it was there by chance, because he was in the respiratory unit, he happened to meet John Saville. I don't know if John has managed to make it yet, or if he's late as usual. I guess being head of the MRC always makes you late for stuff. So John maybe isn't here yet, but I'm sure he will be. And John persuaded Fred it would be a good idea to think of a career in research. And so he approached Andy Rees, who is here, fortunately. With Andy's guidance, Fred obtained a Medical Research Council training fellowship and did his PhD under Andy on inflammatory mechanisms in kidney disease, which was to form most of his subsequent work. After his MRC fellowship, Fred then pretty uniquely went straight on to a National Kidney Research Fund senior fellowship. I don't know if anyone, it used to be called National Kidney Research Fund, it's now called Kidney Research UK, which is a nicer title. I don't know if any of the KRUK people are, hooray! Okay, so there is Kidney Research UK. So they're very generous support. This was a 5-year clinical fellowship, so not a cheap thing. Fred continued his research, collaborating with me and, again, working with Andy Rees to develop his research career. When that finished, Fred then had to go back to the wards to complete his clinical training, which he did successfully at Hammersmith Hospital and also at Charing Cross Hospital. He was then appointed as clinical senior lecturer in the renal section at the old Royal Postgraduate Medical School in 2003. And he was subsequently promoted to reader and then to professor at Imperial in 2016. And he was appointed as the Ken and Mary Minton Chair of Renal Medicine earlier this year. So Fred's main interest throughout his research career has been inflammatory mechanisms in kidney disease, particularly in glomerulonephritis, but also looking at diabetic nephropathy, and more recently at kidney transplantation. And again, Fred will tell you about this, so I don't need to tell you. But throughout his career, he's combined basic laboratory science together with clinical research, and of course, quite a large component of clinical care of the patients, as we all have to do. So Fred has managed to do all of that together. He's also quite remarkable for the number of successful collaborations he's set up. He set up loads of academic collaborations and also collaborations with the pharmaceutical industry. And he collaborates with everyone and anyone, but does it very effectively, even with UCL, which, sorry Alice, there he is. He's doing great work with them. And Fred's work has now reached a stage where, this takes a really long time, where Fred's basic science research is now being translated into clinical trials of new therapeutic agents. And this is, of course, what we all aim to do, and few of us really achieve. So I think it's fantastic that Fred has actually been able to make this transition from work on the bench through to work with patients and clinical studies. So the other characteristic of Fred is Fred is a very modest and indeed a very humble individual, never blows his own trumpet, and always tries to let other people take the limelight. So I'm actually delighted that on this occasion he has to take the limelight. He can't hide his light any longer. So it's a great pleasure to invite Fred to give his inaugural lecture, Challenges in Kidney Disease from Cell Culture to Clinical Trial. Fred. Thank you, Fred.
And thanks for all of you coming along today, and particularly President Gus, and I'm honored that you come and join us today, and Mrs. Minton, Mr. Paul Minton, and I think it is a surprise to myself that we come to a stage as we are now. I remember it wasn't that many years ago. It was over dinner table. One day I mentioned to my wife that I like research so much, I could have given up clinical medicine, but I couldn't see how my research would ever be useful for my patients. So many years have gone by since then, and now I got to eat my words and change my mind of what I say in those years. So maybe a lot of you know me that I'm a very unfocused person, so I thought I'd give myself an outline to pin down what we're going to share with you today. And the most important I want to share with you is that the importance of kidney diseases. And secondly, the experimental approach we've been attempting to get that. When I say that I do mean that because I alone cannot do all these things. It's all my colleagues together working that out. We use methods like cell culture, study of kidney biopsy, experimental models, and clinical trial to hope that we can bring all these basic science to clinical application to benefit our patients. And then, although I would like to sort of sometimes define very small project experiment, the chance is that if we do our science in great depth, every now and then we see there's a wide application. And at the end of that, I'll share with you what wide application there can be. That's how I arrived here in 1977. I never dreamed that I'll be in this country because I come from a family that we cannot afford to go abroad for anything. And it was very thankful that there was a scholarship program at that time allowed me to join this international school. And one of these features, this international school, is that most of the students there are people who get national scholarship to come and join in together. And as a 17-year-old, it's an eye-opener. The first time we come across culture of many people in one place for 2 years. And that made a lot of difference so many years later. And I think those early years of international collaborations or communication is very important. And then after that, I went to Cambridge. The main thing I want to highlight in Cambridge is that besides the good supervision they provide in those days, is I was in trouble then. So by my second year, despite all the grants and loans I have, I ran out of money. And then I remember there was one day I got a summons from the college masters for me to see him. I thought I was in deep trouble. So the first question he asked me is that, I heard that you don't have money, right? And do you have money to eat? If you don't have money to eat, then I'll give you some cash right away. So it worked out that I just got enough cash to last for the first term. So he reassured me under whatever circumstances, he makes sure I don't need to give up my time in Selwyn. And then throughout the rest of my time in Selwyn, Selwyn have been really generous to me. And I think that also made me feel very different about how to practice medicine all the years afterwards. It's the generosity of people to me, make me feel that what I'm doing now should be of benefit to others as well. So after the early years of training, when I came to Hammersmith Hospital at that time, this building was like that at that time, and then I have the opportunity to do research and clinical service. And as Charles mentioned, then I have the opportunity to meet Professor Rees at that time to talk about my career direction. And he was really helpful. So he was offering me any help that I need, both in clinical and research. And before I leave the room, he actually offered me a job. And then I was very excited. And then he tried to explain to me what the project is about. And I was stuck there because all the words he mentioned is completely new to me. He mentioned the word cytokine, and he can see from my face I haven't heard of the word before. And then the next thing he said is that he thought, okay, if you change the subject about research methodology, like polymerase chain reaction, I would light up easier. And again, I was stuck there. And he got to draw on the blackboard how the PCR work. So that's how I started my research. But certainly in those days, I thought that for me to do research is really to learn how to read the research paper. And hopefully, I'm a bit better at that now than before. And so coming back to the kidney, and the kidney is quite a vital organ to us. And the real challenge to us is that it does so many vital functions, like clear waste substance from the body, balance the salt and water, and many more functions. If things start to go wrong, the patient can be very ill. And this is the picture I've been sort of trying to remind myself that the kidney is a very delicate organ. Many things can stress out or do harm to the kidney, ranging from autoantibody, high blood pressure, or metabolic disorder, causing inflammation, scarring, and kidney failure. And you can imagine, ideally, the kidney should look nice and smooth like that. But if a patient silently have kidney illness for many years, some of them will end up with a lot of scar tissue, which is not functioning at the end. And in practice, what we're facing is that quite often the patient doesn't have much symptoms in the beginning. And that by the time they got symptoms, the option of treatment are quite limited. And a lot of therapy we have, they do have a lot of side effects, although they work to a certain extent. And one of the major advances since the 1960s have been dialysis and transplantation. And they're very effective. They're all life-saving and change the way people are. But they do come with a lot of economic burden, a lot of complications as well. So ideally, I would still like to go back to the beginning and prevent patients from getting to kidney failure. Now, with the benefit of MRC training fellowship in those days, one of the things I have learned is that about the mechanism, how different protein can contribute to inflammation that mediate kidney injury. And in some early stage experiment, in those days, we've shown that using specific inhibitor, we can reduce the amount of inflammation and injury. And this is one of the slides I can summarize some of these ideas. This is a renal biopsy of a patient with glomerulonephritis. And you can see all this brown color staining there. These are special staining for inflammatory cell macrophage. And the question is, how do they get there? So we've done a lot of work at that time to look at how cells penetrate the kidney structure there and eventually damaging them. And one of the paradigm at that time was that inflammatory cell can be from the circulation in the lumen of blood vessel. They can, through various stimulation, including inflammatory protein like chemokines, they would cause them to migrate across from the blood lumen level into the site of inflammation and causing kidney damage. And it's very useful at that time that while I was doing all these scientific experiments, Charles always asked me, why don't you do something for the patient? I keep on telling him, it's too difficult to do, I don't know how to do it, I have all sorts of excuses. But after a few months, eventually I come around to do the experiment with him together. These are very straightforward experiments. Based on the scientific understanding we have, we collected urine from patients with glomerulonephritis in the clinic. And some of them are in remission, inactive, some of them are active disease. To our amazement, it was so clear-cut the patient with active kidney disease, they got a lot of inflammatory cytokine in the urine, and which is a very non-invasive understanding the pathogenesis of disease in patients. And then with the help of Kidney Research UK, I managed to carry out that a bit further. And particularly, I started to learn the lessons that collaboration is really important. At that time, we've set up various collaborations, both academically and with the industry. Now, coming back to IgA nephropathy, which is a small area I focus on today, probably all of you wonder, why do I choose such a small topic? There was two reasons. The first one is a logical one. This is the most common cause of glomerulonephritis worldwide, wherever you go, Far East, and even Western Europe, there's a lot of them, including London. And the key feature is like that this is a kidney biopsy of patients, and you can see that this area of the kidney, they are much more thickened than they should be. These are abnormal changes in IgA nephropathy. Now, superficial, when we look at like that, it's very hard to tell what's really going on. But when people use immunostaining, here you can see this green color fluorescence. These are deposition of IgA antibody, which normally should be fighting infection and protect our health. But for a reason we only partially understand, they got stuck in the kidney and causing inflammation and scarring. And I remember this is a disease which is only known for about 49 years, 50 years. I think still to be 50 years anniversary next year that the disease has been discovered. When I was a medical student, I read the textbook. They always say that, oh, IgA nephropathy may be okay, some patients do well. But in fact, the longer we know the disease, the more distressing it is. Because we know that about 1/3 of the patient, either soon or later, may end up needing dialysis transplantation. So I think the years of experience is causing us more distress rather than security. Now, we've been looking for a lot of mechanism to understand what is behind IgA nephropathy. And I can tell you, we've been going through so many pathways. Surprisingly, eventually, we found one pathway which is more promising than others, spleen tyrosine kinase. The reason this is important is that it is in a lot of the cells of our body, both white blood cells and also kidney cells and other organs as well. But they are not always switched on. They tend to get switched on when there is something happening, like during there's an antibody reactions. And so you can imagine that in patients, when the abnormal IgA gets stuck to the kidney, there's a small chance this enzyme may be switched on. And when we first started research at that time, we know the leukocytes are very involved in spleen tyrosine kinase. but we don't know for certain at that time whether kidney cell was involved. But the work over the last 10 years we have done show that they are very involved in kidney disease. And furthermore, what's interesting is that they're always involved in other mechanisms like B cell activation and also the upstream production of antibodies. So this is a hypothesis we have at that time. This hypothesis is not out of knowledge, it's out of speculation and unknown at that time. So we think that in IgA nephropathy, maybe the IgA complex stick to the kidney cells and causing release of inflammatory mediator. And that is more or less generally agreed across the world. The question is what really happened to cause that? And we hypothesized that the spleen tyrosine kinase being activated with phosphate group add to it and causing this production of cytokines. And it was quite a bold speculation. The question is, do we have any evidence? So the first thing we did is that we look at samples of kidney cells and to see if we can do a study with them. But the first thing I realized is that that's where friends are needed. My knowledge of purifying IgA from patients is non-existent. Thankfully, I was in Leicester in my early days, so I go and contact John Feely and his colleague, and they right away, they start this collaboration. And from what I've known of is I have emptied their 10-year storage of serum in the freezer they've been keeping. So I'm glad they still regard me as a friend at the moment. So what we did in those days is that, or what Leicester did is that they collected serum from patients and then purified the IgA from them. And then I got the easy bit. I make the tissue culture plate with kidney cells there. And then I put this precious antibody from Leicester in the cell culture system here. And then as a result of that, they start to release the inflammatory mediator that you will see in patients. So that's all very well. And then we start to measure the cytokine being produced. They are cytokine which is involving migration of inflammatory cells in the kidney. They are cytokine involved in inflammation generally. And some of the growth factor involving abnormal cell proliferation, which are all hallmarks of IgA nephropathy. And so having set up the system, then we try to find the first piece of evidence that SYK is involved in that. So we done special Western blotting to look at expression of these activated SYK. Now, there was a lot of Western blot involved. I thought it's easy to show you an example picture of densitometry. In the baseline level, a small amount of that can be detected. But once they're exposed to IgA, within about 2 minutes, you can see this increase of the activating enzyme. And they peak in 5 minutes and then stay up for some time to come. So this is the first evidence that the molecule is being expressed in IgA stimulation. And the question is, having seen something going up and down doesn't mean they have a function. So in order to demonstrate that what function they have, we use two approaches. One thing is a pharmacological inhibitor. The other thing is a molecular method. So the pharmacology inhibitor, that's where our collaboration is very helpful. So through a collaboration with the small biotech company in San Francisco, they kindly provide us of the SYK inhibitor they are using in clinical development. And this inhibitor, they would occupy the active site of the enzyme and stop further downstream inflammation action. So this is a theory. The question is it true? And then so we do it in this experiment. What we've done is that we propose that if our hypothesis can be true, then we add the SYK inhibitor there. We should downregulate the inflammatory mediator production. So that's our prediction. The inhibitor block the enzyme, there should be less cytokine being produced. So this is experimental results. And so when we did the experiment, all this red color one are increasing concentration of the inhibitor. So the messenger RNA of these cytokines being upregulated by IgA, you can see this dose-dependent reduction of the MCP1 messengers. The question is, as I learned from my PhD at that time, seeing the messenger is not the same as seeing the protein. So we do the immunoassay confirming that that's converted into reduction of protein production. So it looked like there's two things happening here. One thing is that the IgA causing this inflammatory mediator dependent on SYK pathway. And secondly, this inhibitor from the pharmaceutical industry may actually be working, at least in the cell culture system. Now, we all know that merging one mediator in a way it is potentially meaningless because in our body, many molecules work together in a coherent way. So we look at a wider network of cytokine. And these are what we have looked at, as you've seen from the picture earlier on. What's interesting is that all these 6 molecules, they were being downregulated the same way by the SYK inhibitors, confirming, number one, it's not a one-off phenomenon. And also there's a meaning to that. These are not random molecules. You can see that they work coherently together in inflammation and abnormal cell proliferation. So that's one problem. I remember I showed the result to Charles at that time. He was very pleased with the results. And he asked me the question, is it true? And I told him I'm not sure. Because you can easily do an experiment and get some data. To actually believe the data is a different story. So we repeat the experiment many times. We keep on getting the same result. At the end, we thought, okay, there's one more thing we got to do. We got to change a different way to stop the SYK enzyme. And this time we use a molecular method to silence the SYK synthesis. And this is the silencing RNA technique. So you can imagine the SYK would not manage to be synthesized. The enzyme can't do the function. If the prediction is right, then the cytokine production would disappear. Of course, in real life, life is never like that. So what actually happens is that in here, you can see that in the green arrow, this is a plot of the protein level of this SYK. The technology only allowed me to block 50% of the enzyme synthesis at that time. So you can see this is a quantitation here. So it was quite concerning. Is it going to work? Because we all know that in biological system, 50% may be sufficient to maintain the inflammation. But thankfully, when we do the inflammatory mediator measurement, you can see that here, there was a reduction of the inflammatory mediator, although we only block up about 50% of enzyme activity. And then again, we measured the 6 mediator we mentioned earlier on. Again, it was all confirmed. So it looked like that it's a little bit more than coincident. Both the pharmacological inhibitor and as well as the molecular method produce the same results. And it's all very well to do it on the test tube or tissue culture plate. Does it happen in real life in a patient? So this is a summary of a lot of work done by Steve McAdoo, who is one of the senior research fellow in the audience. During his PhD, he done a lot of hard work looking at the expression of SYK in renal biopsy of patients. To get a long story short, you can see this brown color staining there, the expression of SYK. And when he quantified them, he found that the more severe disease of IgA nephropathy got more SYK expression. So it looked like not only they express in cell culture, they also show the severity of disease. And not only in IgA nephropathy, when he looked at a wider range of glomerulonephritis, again, he sees this picture that the more severe the kidney disease is, the more this enzyme being upregulated. So to summarize that, what we got here is that we got a tissue culture system confirming SYK associated with inflammation. And then that is confirmed on biopsy of tissue from patients. Now, if we want to move something like that from a tissue culture to a clinical translation, we need to demonstrate that this inhibitor will work in a more complex environment. So that's where experimental model is important. Thankfully, in our laboratory, together with Charles over the years, we have developed several models of glomerulonephritis. And we have tested this compound in 3 different models. And they all come down to the same conclusion, that this inhibitor not only work in a test tube, they will work in the whole animal model of glomerulonephritis. I'll just show you some example. So this is a model where we infuse an antibody at basement membrane of the kidney in vivo. They would cause loss of kidney function and tissue damage. When we give the inhibitor orally twice a day in experimental model, there are some very dramatic results, like the histology, which is where inflamed and damaged in the vehicle group, they were being treated very effectively by the inhibitor, both low dose and high dose. And this is the best picture to show. You remember the kidney biopsy was shown in the patient earlier on. This infiltrates the inflammatory cell there. In the vehicle group, you see all this macrophage, but with low dose and high dose treatment, you can see only a small number and none of them in the high dose treatment. So it looked like mirror the situation that the clinical pathology of patients that we demonstrate animal model can be treated by this medication. Now, we know that you can't ask the patient, please come along to see me one day before you get your disease. We can't do that. So the patient always come along when they're ill already. So in this experiment, we've done a more challenging way. We've done a group of treatment. We started 4 days after the induction of disease. By that time, there's proteinuria, very much like patient coming to our clinic. And what is interesting, as I can see here, the macrophage number was still effectively stopped by this treatment when it's treated late. And then the most beautiful experiment is this one, done by Steve McAdoo, I mentioned earlier on. So he done a more challenging model where he gave an autoantigen there to cause the inflammation. And they make antibody and then proteinuria. And he only started treating them when the proteinuria started. By that time, if you do a biopsy, there's a lot of fluorescent antibody deposition. And the result is quite amazing. You can see that in this model, there's gradual development of hematuria, which is blood in the urine sample, and also rising amount of protein in the urine, which is exactly how patients are being referred to our renal clinic. But when he gives the treatment, only on day 18 after the induction of disease, you can see that the hematuria disappear and the protein in the urine disappears as well. We thought that was exciting until we see the biopsy material. What actually happens is that the treatment not only reduces the blood in the urine, protein in the urine, they actually protect the kidney appearance. The vehicle group got a lot of kidney damage, which is reduced by the treatment to minimum level. So to summarize, what we have shown so far is that using experimental model, we have shown that by targeting SYK using pharmacological inhibitor, we can reverse pathological changes even after onset of disease. And one of the concerns we have at that time is that we are I think the only group around the world keep on persisting on this investigation. It comes to a situation we thought, is it really true? If only us producing these results, it would be concerning. But thankfully, when we leak out our results to some of our competitors, they become our friends, because what happens is that they carry on doing experiments along the line of what we have and confirm all the findings we have, both on the clinical biopsy and animal model. And that would provide the environment at that time that we talk to our collaborator in industry to ask them, can we develop a clinical trial together? It took us a few years to get the trial set up. And but eventually, with the support of industry and also Kidney Research UK, we started a phase 2 multi-center trial of IgA nephropathy, the disease I've shown you so far. And one of the major elements of this trial is that on day 1 of the trial design, we actually invited a patient with IgA nephropathy come into our group. So he was actually telling us what is sensible, what is not sensible from a patient point of view. So subsequently, when the application go for research ethics committee, it was no problem at all, because we were actually a patient-centered design rather than a sort of our blue design. And at the end, we have 20 collaborating centers across both Europe, Far East, UK, and USA. Some of you always ask me, why do I decide to invite all this country? It's out of desperation. I remember when I first designed the trial, people say that your trial is not going to work. You're not going to find the patient you need to enter the trial. So the more desperate I am, I got to call on all my old friends and previous research fellow. And that's how the whole thing started. And I think it's a good lesson for me, is that sometimes when we feel that we're so capable, in fact, we're not doing much. So on the other hand, when we think that we're dependent on help, that's the time we actually build a better research network than ever. So the trial actually started in October 2014. It didn't go well initially. We can hardly find any patient. And, but we saw persevere and hope that something good would happen. And our primary endpoint objective is make sure the drug is efficient and safe for the patient. And this is a clinical trial. It's a trial, double-blind randomized control trial involving placebo, high dose and low dose treatment. And the treatment duration is for 24 weeks. And the endpoint we look at is whether there's improvement of proteinuria, histological change of the kidney. So for the patient who agree to have a follow-up biopsy, they would have a histology at 24 weeks of treatment to compare their baseline, but it's total voluntary basis. And then we also want to look at whether the histology in the beginning would help us to predict the clinical outcome. So that's what we done at the end. These are the 20 centers across the world. And thankfully, in August this year, we have completed the recruitment of the patient for the trial. And UK have done very well. We recruit 23 patients, same number as USA, and then very helpful support from Far East and Europe as well. Now, I got to emphasize the Far East, but this is very important. People always ask the question, because this condition is so common, is the disease in Far East the same as the one in UK? So hopefully by the time we unblind our data, we will see whether both the pathology and clinical response is the same across the world. So although it looked like that we have made small progress on one clinical trial, and we wouldn't know the results until February, but we have some plan for further development. Based on our preclinical data in the laboratory and the disease mechanism, we have started an area of research on transplantation rejection, and in near future also recurrent or primary disease in the transplant as well. And I'm very thankful the support of the KL UK and to give us a program grant for that. And to Charles' delight, I'm also interested in doing vasculitis, which is quite supported by animal model as well. And so to summarize where we are, we start up by doing a cell culture experiment and then confirm on kidney biopsy, and then the preclinical model help us to know that what we see in the test tube can be happening in a bigger scale. The clinical trial, we reach a stage where we have completed recruitment now. So the last patient entered the trial will finish treatment by February. And I have apologized to my wife beforehand recently. I say that come February, probably I wouldn't have time for holiday or eat or anything like that. So over the years, my wife has been very supportive, even when I say my research may not be useful, and also my crazy working hours. And I think you can see in the middle of all of that, the patient's really the center of the focus of all this work. And particularly recently, we have Kidney Research UK help us to set up a patient support group for a clinical trial. And also, I learned the lesson a lot from the patient point of view. It doesn't matter how challenging the disease is. The patient actually group themselves together and invite collaboration. And of course, you see all this work, a clinical translation, and also the original study. A lot of them are really hard work for all my NHS colleagues. So I'm not going to read out name one by one, but I think the first two persons very important. Andy Rees, he accepted me as a research fellow even when I don't know what a cytokine is. And Jennifer Smith, so she is the one who teach me everything about the research. And even more amazingly, the more key experiment of experimental glomerulonephritis with SYK inhibitor was actually carried out by her to make the breakthrough that we are now. And a lot of collaborators here, both from my friends from Leicester and pharmaceutical industry, Kidney Research UK, and the funding body. And of course, this work is very important, that being helped by Mrs. Minton and her family to help us to take it further. Otherwise, I think we're quite limited what we can achieve. And there are other work that I haven't described here, because as Charles always know that I'm not very focused. I'm happy to work on anything that have patient relevance. So you can divide it here. On this side, it's all to do with inflammation. On this side is to do with fibrosis. Great, thanks for your attention.
So, Fred, that was wonderful, fantastic, and you kept so well to time that I'd like to ask you if you're prepared to take one or two questions from the audience. I know it's not necessary at an inaugural lecture, but if you're prepared to.
Yes, I'll be delighted to do that, yeah.
Lovely. Okay, so let's have some really challenging questions for Fred. So hand up at the back.
Fred, well done. Congratulations.
Thank you.
You did talk about wider applications, and you speculate which other disease outside kidney would this approach be useful?
And I think autoimmune systemic disease would be a very, very good target for this treatment. And so that's why more recently I start to think about systemic vasculitis and also lupus disease, because I think the role of the immune system is so important there, so they may be amenable to this treatment.
You want to say something more about the transplant? Well,
Yeah.
because nothing works in antibody-mediated rejection, does it? So why should your compound work?
So that's interesting, because I wasn't thinking about that originally, but because we see the challenge of the need of the patient, so we actually did experiments showing that the antibody-mediated response in preclinical model seemed to link with SYK. But even more amazingly, when Steve McAdoo done some immunostaining of transplant rejection tissue, we see that this enzyme again is upregulated in the antibody-mediated rejection. So I think the important scientific mechanism actually matched with clinical data. So despite I was skeptical at the beginning, now I find that it's a very important area to develop.
Perfect. Question at the back.
Hi, Justin.
All I can say is, having been with you in respiratory medicine in 1989, you made
Yes.
a very good choice to move into renal medicine. My question is IgA critical here? And will other immunoglobulin subclasses signal via SYK in a similar way? So maybe an vasculitis or the other diseases?
Yeah, that's a very good question. In fact, the IgA link with SYK is very speculative right at the beginning, because people have been arguing about what is the receptor of IgA. If you think about other immunoglobulin, IgG, their link for SYK is even stronger. So I would think that a lot of antibody and immune complex disease would be involving SYK in some way.
Andy Rees,
Fred,
about whom we've heard a lot this evening.
yeah. Fred, you know that 1,000,001 experiments have been done using various inhibitors of various models of glomerulonephritis. And almost universally, they cause a 50% reduction in injury. It seems to me that the SYK inhibitor is unique in causing close to 100%. Now, one of the things that I was wondering is that leukocytes, clearly macrophages in particular, are powerfully affected by SYK. And you showed in your tissue culture that mesangial cells, i.e. the cells that are attacked as well as the attacking cells, also have SYK that is important. Do you think the fact that you're hitting both the target of injury and the injuring cell has anything to do with it? And in the other models, when you've looked at tissue biopsies from patients, do you see SYK activated in the infiltrating leukocytes as well as in the infiltrated glomerular cells?
Yeah, Andy, that's a very good question. So coming back to renal biopsy first, we find that about 50 or 60% of the staining of SYK is in the macrophage, and the rest of them are outside the macrophage. So it looks like that your suggestion is spot on. And what is interesting is that at the time when we start the project, we actually asked a question: does the SYK affect one population more than the others? And we set up cell culture experiment for both populations. It looked like both populations are affected by SYK inhibitor as well. So I think you're quite right that probably that's why this pathway is more important for intervention than many things we have tried before.
Thank you very much.
Thanks.
Wonderful talk.
Thanks.
Other questions or comments or anything? No? Oh, one over there. So, yeah.
Have you done a preliminary outcome study in the patients, and if not, when do you expect some early results?
So we can definitely say about the safety profile. There's an independent safety committee that I don't even know their names, but they send regular report for safety. Look like the safety signal for this trial is actually better than other trials they've done before with this inhibitor. And the second thing about efficacy, they've done something very interesting. The safety committee need to say that, find some efficacy data before they allow us to go for the high dose. So they have shown that there is improvement of proteinuria in the inhibitor treated group compared to the placebo. But they keep us double blind, so only a safety committee know those data. They released a sort of, I think, 2-sentence headline statement a few months ago.
If there are no other pressing questions. Fred, you can sit down now.
Great, thanks.
And I'd like to invite Professor David Taub to give the vote of thanks. David.
Thank you. So, Fred, thank you for a fantastic lecture. I don't think anyone's gone to sleep, which is sometimes a temptation on afternoons like this, yes, particularly in the front row. And neither of my colleagues demonstrated any signs of sleep apnea, which of course is very reassuring. I think before I thank you personally, it would be really very nice if we thanked Mary Minton and her family for endowing your chair. This is actually quite a substantial endowment and is perhaps new for us as a renal unit and a renal department, because I don't think we've had such an endowment and such a fantastic opportunity. So I don't know, Mary, if you're feeling strong enough or awake to say anything, but if you wish, it would be nice for you to say a few words.
You're going to stay there, aren't you?
Sorry?
You're going to stay here.
I'm not running away, actually.
Well, I think the first thing that I must say is that I know nothing about kidneys. Neither does my son, and neither did my husband. So you may wonder why a family like ours with no medical knowledge at all would want to endow a chair of renal research. And of course the reason is my husband had kidney disease, and Professor Taub knows the name of it and I've forgotten. Well, whatever it was, yeah. But briefly, the background to that was that Ken had a heart attack, his first heart attack, in 1980, and after that until 2009 he led a fairly normal life, normal for a person with a cardiac history, and started to be ill in 2009. And at that point our local doctors said that, well, this is your heart failing after all this time, you've been very lucky, and we'll increase the dose of your tablets and we'll give you what we call diuretics to get rid of all this swelling, and how about giving up work? You're over 70 anyway. Well, Ken wasn't that sort of man, he wasn't going to take that easily. So we came to London and saw a cardiologist for a second opinion, and he said, well, you've got kidney disease. Do you know a kidney specialist? And we didn't. And he said, well, I do. There's one in this building. And it was Professor David Taub. And that's how we came to meet him. And Ken lived until the end of 2015. And there were, that's almost 7 years, and there were 7 good years. And there were good quality of life. But of course he was a kidney patient all that time. And he was being looked after by Professor Tauber and the Hammersmith Hospital. And yeah, we all coped very well. And no, he didn't give up work. Well, I knew he never would do. He took on another job instead. So he bought a factory in South Africa along with a friend half his age. The idea was that he would employ people who were not employed in South Africa, where the unemployment rate is sky high, and the people who are unemployed tend to have very little education, so they can't have anything to offer for a job. That factory is still existing and doing well, thanks to Ken. So he did use those years very well, and he did a lot of good in those 7 years. But each time we went to the Hammersmith Hospital, we saw the buildings at the far end, and we knew it was Imperial College, and we knew there were laboratories in there, and people did research in there, and that's about all we did know. We didn't know where the funding came from. I vaguely thought it was National Health, but we just didn't know. And it was quite by chance that we found out that money was needed. So we decided to make a donation, and there were lots of suggestions of what it could be used for. And Ken said to Professor Taub, well, what would be the top of your wish list? And he said, oh, a chair of renal research or renal medicine or something. And that was a lot more than we'd intended to give.
You didn't say that.
So we went home and talked about it, and we thought, well, we do have that money. It would be a good way of spending it. It would help a lot more people. Then we rang our son, Paul, in New York, and we said, Paul, we're thinking of spending your inheritance. In fact, we're going to give it away. Do you mind? And Paul, bless him, said, Mum and Dad, it's your money. You can do whatever you want with it. You don't have to leave me anything. So we endowed a chair. And we put our names on it rather than do it anonymously. We don't normally blow our own trumpets. But we did that so that should anybody in the future ask you who were those people and why did they put the names on it, you could say, well, they were thanking Professor David for giving Ken those extra years. They were thanking the Hammersmith Hospital because the staff there were wonderful. And they were supporting those people in Imperial College that they didn't even know, who were doing all the research to help people like Ken with kidney disease. So I think my message to you will be, if you know of anybody who has a reason to thank you for research into kidneys, and there must be a lot of people out there, we're not unique. So why not suggest to them that they make a donation and, well, put the money on the table. If you think that that's too blunt, you could just tell them my story instead. Thank you.
Thank you, Mary. Thank you, Paul. I didn't realize it was your inheritance. So Fred, you've got an awful lot to live up to. Yeah? Not only you've got to sort of come up with the goods, but you've got this to think about for the rest of your career. I'm just going to briefly move on to you, Fred, because Charles has sort of outlined your career and your beginnings. And I'm sorry, Selwyn was such a difficult place in some ways, but again, such a wonderful place in the way they treated you. And of course, my own career and beginning have sort of similar parallels to yours, interestingly. I think one of the things that really distinguishes you, I'm not going to go through the science, is the fact that you're such a decent and humble man. And until I got someone to start printing out your CV, I didn't realize actually how much you've done and how much, hopefully, you're going to do. And again, one of the most extraordinary things is you outlined in a very humble way, really with your sort of discovery of sick in IgA nephropathy, and of course, your very rapid promotion into other fields, thankfully transplantation, and hopefully what a fantastic difference this agent is going to make to patients with nephritis and also patients with rejection in transplantation and recurrent disease. You've also got a whole lot of other molecules sort of hidden away, some of which we know about, but again, I know that you've got up your sleeve and you've got various other collaborations going, not only with industry, but with other groups. So really, I don't think there's anything more to say, except I remember on one occasion when I think you were perhaps having a slightly down moment, and Charles and I met you for coffee. I think it was something to do with promotion or something like that. The usual sort of shenanigans that goes on in Imperial College. And we were sort of trying to sort of bolster you up. And I remember Charles and I said, you really do hide your light under a bushel. And you sort of looked at us, because I know that you're a religious man. And I remember this conversation which you had. Of course, you were subsequently very successful and have been very successful. And when I was thinking about what I should say about you, I thought, well, I'd better go and look out what actually hiding your light under a bushel means and where it comes from. So I went and consulted Google and Wikipedia, and I've got the Matthew 5:15 version, which of course you know about, and I'm going to read it out because I thought it was very resonant in terms of what you are, what you've done, and what you will do. So it reads like this, and of course Mary and your father, will appreciate this. So it says, neither do men light a candle and put it under a bushel, but on a candlestick. So remember that, Fred. And it giveth light unto all that are in the house. Let your light so shine before men that they may see your good works and glorify your Father which is in heaven. Thank you.
Great, thank you very much, David, and thank you again, Fred. Alice, are you wishing to say anything? No.
Such heartfelt words are just wonderful. Thank you so much.
Great, thank you very much. So I'd like to close proceedings now. I'd like to thank you all so much for coming. It's meant so much to Fred to see so many people, particularly loads of colleagues I recognise from years ago, have made their way here. So thank you all so much for doing this. And again, thanks very much to Mary and her family for their incredibly generous endowment, which has made this evening possible. So I'd now like to invite you to come and share some wine and canapes downstairs in the reception. And thank you all again.